You want to sketch this one yourself or get out the graphing calculator? Can we handle this one?
It's pretty easy. You can take a look at now.
Okay. All right, so what's this look like?
I'm gonna have a problem. Yeah.
Okay, and then this is the x-axis. That I not missed. And then this is a vertical line at 4. Okay, so you can see the shape that we've penned in here. Looks like that. And we're going to spin it around a whole bunch of different stuff. So the first thing that we're going to spin it around is the x-axis. Right, so that's going this way. So we're going to take this thing and go that way. All right. So I integral of top minus bottom, technically, even though this is a disk, right? Because there's no space. Right, so I have no hole. So this one is going to be a disk method. So top minus bottom, yes, my top is going to be square root of x squared minus the bottom, which is
Yeah. Y equals 0.
so 0
0.
squared. So do I even need that? Dx. All right, from where to where?
0 to 4.
0 to 4. All right, there we go. And I like this one because my square root, I get x, and then I'm going to get x squared over 2 times pi. And I need to evaluate that from 0 to 4. When I plug in 4, I'm going to get 16 over 2, which is 8. So I'm going to get 8 pi minus when I plug in 0, 0. So I just get 8 pi. All right, well, that wasn't so bad. B. All right, B, I'm going around the y-axis. Let's change the color here a little bit. So now I'm going this way. All right, that changes things a little bit. So what's that going to change for us? Most noticeably? Yeah, what's the top and bottom now?
0 and 2.
Okay, well that's going to be my bounds are going to be 0 and 2.
bound.
Okay, you're right, because I had to switch to y, so I'm going from 0 to 2 now. So I'm going to go 0 to 2. Still going to have my pi out here. Top, quote unquote, 4. Okay. Squared minus bottom.
It's not going to be the x-axis.
Correct. No, not the x-axis.
The finger.
It's bottom. Because now we're coming in.
Square root of x.
So it's the square root of x. Now, it's that formula, but because we're going the other way now, I want that to be solved for x. So this isn't good enough. I need to get x by itself. So we need to use y squared instead, because it's got to have y's in it, which means that I'm looking for the things to solve for x. So when we're going up and down, we want y to equal things, right? Y equals y equals. When we're going side to side, we want it to be x equals x equals. So you get to use the same formula, yes, but I had to solve it for x instead. So I'm using this. So that's what's going in here, y squared squared dy. We follow that? I never liked the side-to-side ones because whereas I could usually figure out the top and bottom, my biggest mistake was always leaving it as y equals. All right, but when you go side to side now, you have to go x equals Okay. So 16 minus y to the fourth dy. Integrating that, it's pretty easy. 16y minus y to the fifth over 5. Got a pi out here. I got to do it from 0 to 2. When I plug in 2, I'm going to get 32 minus 32 fifths. When I plug in 0, I'm just going to get 0. All right, so if I make this one into fifths, 160 minus 32, which is 128 over 5 pi. Alrighty. That was this one. This one. I'm going to go around the line x equals 4. Okay, so we're going to get a mound here. The Hopi Indians. I don't think it was the Hopis. The Hoplo. Hoplo. Those are mound builders. I'm sure they were doing calculus while they were trying to bury their dead. Okay, so C. Now, when we're basing this one, we want to base now that I've shifted my rotation off of an axis, it's going to change things up a little bit. Now, I'm still going this way, so am I using dy's or dx's? Dy's. So everything still needs to be in terms of y, right? So I'm still using this guy. Now, is this going to be a disk method or a washer method, even though it's shifted off of its axes? Am I going to have a gap in the middle? No. Now, but if you want to think of everything in terms of washer method, you can. Okay? So I'm going from 4. So I'm going to have 4s in my problem. I'm still going to have the pi out here. I'm still going from 0 to 2 because it's the y one, so I have to work my way up because I'm going from there to there. Right? Now, you want to go outer minus inner. Right? So from your axis of rotation. So if my axis of rotation is right here, and I go out, my outer bound is going to be the curve, which is what formula for us? No.
Oh.
Y squared, because we had to solve, because we're going this way, we had to solve for x. All right, so this one's going to be y squared, and since it's 4 over, we go 4 minus that y squared. That's my outer, and that's squared, minus inner. Right, now this one, and I'm putting that out there because I'm trying to treat them all like washer, even though this one's not a washer. So what's my inner? Well, I guess technically it's 4. Right, 4 minus 4 then. Because you always go from where you shifted it minus where it ends. Squared. So I'm really not going to have one, which makes sense because you said it was disk method, so I should only have the one thing. Right? But if you want to treat everything like washer, that's kind of how I look at it now. So it's a little bit easier so that I have less to remember. But this is just going to turn out to be 0 anyway. So I'm just going to get 4 minus y squared squared dy because this is nothing. All right, what should I do first? Can I just integrate it the way it is? Okay, what am I going to get when I FOIL it? 16 minus, there's an 8, plus y to the fourth dy. Pi. All right, integrate that. So 16y minus 8y cubed over 3 plus y to the fifth over 5. All times the pi, going from 0 to 2. Plug in my 2. I get 32 minus 8 times 8 over 3 plus 32 over 5. When I subtract off this one, I plug in 0. I'm just going to get 0 again, so I don't need it. All right, so I get 32 minus 64 thirds plus 32 fifths. I need a common denominator. What should I use?
15.
All right, let's do the easy ones first. So this one times 3 is 96. This one times 5 is 320. This one times 15. I don't know that one. I have a calculator up here. I do not.
No, Mr. Gorsuch used to have
Ill
math teacher.
prepared.
They could do any three-digit number.
Well, he's an amazing man. I am just a man.
So here's the four-digit number.
480. So 480 minus 320 plus 96. 256 over 15 pi. That's your volume for that one. All right, and then my last one, the line x equals 6. Okay, definitely still a washer, right? And we're still going this way, so we're still dealing with x equals stuff, so we're dealing with the y's, which means, again, using this guy, right? And this one's going to be much clearer on using the washer, I think, for you. So we know that I'm going to have my integral, the pi out here, still going from 0 to 2. Now, we start at my axis of rotation, and we go outer. Okay, and where I started then, so we'll go 6 minus y squared. Okay? So from our starting point, squared, minus inner.
So 6 minus 4.
6 minus 4. And I'm going to write it like that for now. 6 minus 4 squared. All of that dy. Starting to follow it a little bit better. I think after a little bit of practice, they kind of start falling together. And that's why I treat everything like a washer method now. So I'm always looking for outer, inner, even if my inner is 0. Right? Because then it's just going to turn it into a disk method anyways. All right, so I got pi 0 to 2, 6 minus y squared minus, this is going to be 2 squared dy. What should I be doing here before I integrate? And then I'll combine like terms. So I know I'm going to get 4 there. Here I'm going to get 36 minus 12y squared plus y to the 4th. And then when I combine like terms, I'm going to get 32 minus 12y squared plus y to the 4th dy. And then we can integrate it. Integrating is the easy part. 32y minus 12y to the 3rd over 3 plus y to the 5th over 5. Still got a pi out here. Evaluating from 0 to 2. I can simplify in there a little bit. 32y minus 4y cubed plus y to the 5th over 5 from 0 to 2. All right, let's plug things in. If I plug in 2, I'm going to get 64 minus 32 plus 32 fifths. When I plug in 0, I'm just going to get 0. So here I've got 32 plus 32 fifths. It's 160 fifths plus 32 fifths. I'm going to get a 192 fifths times pi. Pretty sure the integration is going to be the easy part. It's always the setup that's the challenge. All right, so just try to keep doing them all the same way is my suggestion to you guys. So when it's on the axes, it's pretty easy, as long as you're spinning around one of the axes. When you shift it off, that's going to be your starting point minus outer quantity squared minus starting point minus inner quantity squared. FOIL, combine like terms, integrate. All right, so that was a 4-in-1 problem. I'm already tired and I have 3 to go.
Full thing, homework right there.
How comfortable do we feel drawing that picture?
Not freehand.
Not so good? Okay. Well, that's why we have graphic calculators.